For this problem, we want to determine if the points lie on a straight line. We have 3 points, A, B, and C. There are a few ways of doing this problem, but I'm going to show you using the distance formula how you can determine if 3 points are on a straight line, or in other words, are they collinear. So one quick thing I like to do is make a sketch of the graph, actually plot the 3 points on a piece of graph paper. Take a little bit of space here to do that. The first point, A, has coordinates 1, 2. This is A. Point B has coordinates 5, 4. And point C has coordinates 7, 5. So as you can see, we have 3 points here that are plotted on the graph paper, and they look like they are on a straight line, but we can't use a sketch like this to be absolutely certain that the points are on a straight line. So what we need to do is we're going to use the distance formula. We're basically going to find 3 distances. We're going to let the distance from A to B, let that be x. And we're going to also find the distance from B to C. We're going to name that y for now. And then eventually we're going to find the distance from A all the way to C. We're going to call that distance z. Now if the points are collinear or on a straight line, then the 2 shorter distances, x plus y, would have to equal exactly the longer distance, z. So let's apply the distance formula 3 times here. First, we're going to let distance x be the distance from A to B. As you can see, we have the distance formula here. We're going to plug in the values for x1, y1, x2, and y2. So x sub 2 is 5 minus x sub 1, which is 1. 5 minus 1, that quantity squared, plus y sub 2, which is 4, minus y sub 1, which is 2, that quantity squared. Remember the order of operations here. You're going to do the parentheses first, and then the powers, and we're going to add, and then at the end we'll take the square root. So the quantity 5 minus 1 is 4 squared, plus 4 minus 2 is 2 squared. That is going to equal 16 plus 4 underneath the square root, or the square root of 20. You can simplify this radical. The square root of 20 is the same thing as the square root of 4 times 5, and since 4 is a perfect square, we can bring that out, take the square root of 4, and we get a 2 out in front of the square root of 5. So we know the distance from A to B is equal to 2 square root of 5. Let's find the distance from B to C. That's going to be our distance y. Again, using the distance formula, we're plugging in the x and y values for points B and C. Start off with the x values, 7 minus 5 squared plus 5 minus 4 squared, that should be a 4 there, squared, equals, again, parentheses first, 7 minus 5 is 2 squared plus 5 minus 4 is 1 squared, 2 squared plus 1 squared, that is 4 plus 1, and that we get the square root of 5. So we have found distance x, distance y. Let's move on to distance z. So z again is the distance from A all the way to C. That's going to be our longest distance. Applying the distance formula, plugging in first the x values, and then the y values. And that should be a 5 there. Take the square root, do the parentheses first. We're going to get 6 squared plus 5 minus 2 is 3 squared. 6 squared gives us 36 plus 9, the square root of 45. And again, the square root of 45 can be simplified. 45 is the same thing as 9 times 5. And that is 3 square root of 5. So we've actually found our 3 distances. I'm going to circle them in red here. The first distance, x, is the 2 square root of 5. Y is square root of 5. And then finally z all the way over here in the corner is 3 square root of 5. Let's see if x plus y is exactly equal to z. So distance x is 2 square root of 5 plus distance y is the square root of 5. That should equal distance z if the points are collinear, 3 square root of 5. Okay, so we can see by simplifying the left side, 2 square root of 5 plus a square root of 5 is 3 square root of 5. Now both sides are equal, so we can say the points do lie on a straight line. The points are collinear. So the answer to the question, do the points lie on a straight line? The answer is yes.